How's it going, Jason? It's great to get you on the podcast. We've been planning this thing for a little bit, off and on, and now it's kind of like on my end, it's kind of a mad dash to get stuff done before my next kid arrives. So it's like very hectic on my side.
Well, thanks for having me, Joe. It's great to be here. We're excited for it. And congratulations, by the way. It's an exciting time.
Yeah, it's an exciting time to like get back into the suck, as I call it. Like it's just like a blur of those first couple months.
Yeah, absolutely. And then you forget about it later so you can do it again, right?
Yeah.
Not too bad. That first 5 hour night sleep after about 6 week old is perfect.
Oh man, yeah, like it's interesting, I never thought that like I would be able to, I guess, adapt, to the lack of sleep. But, I wear like a fitness tracker. I wear two fitness trackers. One's a Whoop and one's an Apple Watch, right? So in my Whoop, it tells you, your recovery percentage, right? Like how recovered are you, how good you should be feeling throughout the day so you can put in, more work or, better workouts and whatnot. And, in the very beginning, I mean, it'd be like 0%, because you're on 3-4 hours of sleep,
Right.
it's just so brutal. But after a couple of weeks, my body was like well rested after 4 hours of sleep. And I'm like, man, this is wild. And I'm up at 4 a.m. like wide awake with this kid.
Right.
It's the craziest thing. But then like by noon, I'm like crashing, I need an hour nap or something.
For sure. For sure. It's a lot
Man,
like running a startup, actually, at the same time, about the same amount of sleep. So,
yeah. Yeah. I feel like, I don't know. So I do consulting on the side, right? And I really try to limit how I market it so I don't get that much work coming in.
right.
But I could imagine, like focusing more on it. And it's literally like having a newborn, where you're just constantly doing stuff. You're constantly, changing and whatnot, right? Like it's, uh, it's hectic from what I understand.
Yeah, for sure. And for me too, just constantly thinking about how to move the ball forward, what needs to happen next, concerned about the problems that are out there and how you can solve them faster. So your brain's constantly going, but that's also the exciting part of it, right? So you're solving new problems and helping people out. So huge motivating factor to spend that time.
Yeah. Yeah. It's fascinating because it takes a certain kind of mentality to run a startup, right? Like I feel like run a startup and be, somewhat successful, bring in any sort of money really. Right. And I think I heard Tony Robbins talk about it first, where, the purpose of the CEO is of course to like have that vision and, know what needs to get it done and all that sort of stuff, right? Like you're kind of like raising a child as you're raising this business, so to speak. But a key feature of a business leader is someone that can step into any problem, make a quick decision and move on to the next problem, right? And maybe the decision you make is wrong and that's fine. You're the one that takes ownership of it. You're the one that, lives with it and whatnot. Maybe you readjust, recalibrate, make another decision to make the right choice and whatnot. But I think that that's where a lot of people get hung up on, right? And I see that even, in 9 to 5s, right? Where people are mulling over, different scenarios and whatnot. For myself, like I go into it and it's like, 5-minute decision. This
Right.
is what we're doing. This is what I think we should do. This is why I think we should do it. And if someone else disagrees with me that's higher up, that's cool. I'm not tied to it or anything, but still having that mentality really pushes things along. Even if it's an incorrect answer or decision, at least you learn like, hey, oh, that didn't work over there.
Right. For sure. And to be open about that. Yeah. You have to definitely be impatient, I think. And also, like you said, versatile and want to do all the things. I enjoy that, like in my role, being able to jump from a deep technical conversation to a sales call to all those things. And then, yeah, all that background of impatience that comes to it. And then making, smart, quick decisions. And then, like you said, being able to react, what did we learn? And then having a great team around you that can also move fast and react. It sort of always is what's driven me to a startup like, environment at the end of the day. Cause
Yeah.
yeah, you like to move quick. You like to see that progress. And the output of your work, constant reinforcement that you're doing great things.
how do you manage being highly technical and doing sales as well? Because it's like two different sides of the brain almost, right? Like that's how different the two things are. But then a good salesperson or a good tech person that does sales is able to meld between the two. And it took me a long time to kind of figure it out. And I think the best way that I was able to kind of get that thought into my head of how it should be is how I expect from an end user to interact with a vendor, right? What am I looking for from them? I'm looking for straight up answers. I'm not looking for, oh yeah, we can do everything under the sun. I'm looking for, the stuff that they can deliver and whatnot. And so I kind of factor that in from like a sales side where there's also like a business philosophy where it's like you say yes now and then you figure out how to do it later,
Yeah.
right? But like you have to be able to make that quick 5-second decision of, is this even something that I can deliver, and then start working towards it, even if you can't deliver it today.
Although, that's kind of why having that spectrum of ability is helpful, right? So you're making educated decisions in that. There's a lot of context switching. So, and that's I tell people I meet, that's a muscle you can build if you don't think you have it. And it's just like lifting with weights, you can work on moving context and then it's hard at first and tiring and then you get better at it and then better at it. And also, I think I'm maybe benefiting from we're in the cybersecurity industry. And so that sales is a lot of technical sales. And back to exactly what you said, we look to provide value to customers in any conversation that we're having, right? So, what is your problem? What are you dealing with? How are we helping? Is there something else going on? So you're bringing that technical expertise to that sales call today. If you kind of treat them all like, partners with you and, collaboration of the good guys versus the bad guys, then it kind of gets easier at the end of the day.
Yeah, that makes sense. Well, Jason, we kind of went off the deep end right into this business stuff, but we didn't hear anything about your background. So, why don't we backpedal a little bit and, start with your background, right? Like what made you want to get into IT? Did you have experience with it, previously, or, what does that journey look like?
Yeah, for sure. So growing up, loved computers, started programming at an early age, I think on an Apple II. So don't age me there. And then, I just wanted to program, work on computers, went to college, graduated in the 90s, right before the dot-com boom and the Y2K stuff. And then had a technical career for a while, but always interested in product and then got interested in business. And thankfully through a series of promotions and career changes, able to kind of see the entirety of a business. And then, before Invary, I worked for Matterport from their like Series D to their IPO. So spatial data company, got a chance to do a lot of product engineering, temporary CISO. And yeah, it's just that broad experience that kind of led me to the CEO role here at Invary. So technical guy, programmer, all the way to CEO. So it's not something that happens maybe all that often, but definitely can be done.
Huh. Yeah, it's really fascinating, so it sounded like you didn't have like the specific security experience, right? Like a security focused discipline along the way. You kind of learned it maybe as you went, right? Is that
Yeah.
fair to say?
And the products that we built. So, a long time ago, I was at Motorola, in their home division, working on around 6 product lines, IoT and networking. And there's always a security component in that and what you're doing. So it's kind of built into you, right? In your genes and your DNA, so to speak. And then, went on and did more consumer facing IoT work. And then, 2 aspects of security there. There's home security. So we're securing people's, physical property and their life. But then the software itself obviously needs to be highly secure. There's a lot of private information there. So we put a lot of attention and focus and learning into that. And then at Matterport, if you don't know, it's a spatial data company. So they digitize physical places into 3D data. A lot of IP and as a responsible person for their platform, I have big customers saying, I have very important information in your system. Tell me why that's secure, right? So again, I think it's probably good for any organization to have those security practices built into all of the operations, especially in engineering. And yes, there are, specific security roles and cyber roles and CISOs and things, but if you create a culture around security, it helps. And I certainly think we did that. And that's how I learned and ended up ultimately being responsible and eventually running a cyber company.
Yeah, I feel like a lot of companies make the mistake of not really establishing a security culture around their security program, and they just start kind of dictating, different security principles and things that they want, done and secured a certain way, right? Like, it's good in theory, because you're thinking from like a technical perspective and whatnot. But, when it comes down to it, like that's a difficult way to go about it. There's easier ways, I feel.
Yeah, for sure. I mean, and at the end of the day, your customers deserve it and will demand it. And so, you have to make sure it's embedded inside your processes, your culture, like I said, to make sure that you're serving them correctly. And I think if you have that attitude about it, you can do well. And, sometimes a mandated checklist, those are just, hey, the box is checked. A little different than actually, for me, if I'm standing in front of a customer and they're saying, how do you do X, Y, or Z? I want to be able to explain that to them, have them have that confidence in the organization. And what I'm saying, it's super important, much different than like a checkbox on a compliance list.
Sure. Okay. It's interesting. Yeah. Some, I feel like the industry as a whole is kind of, in limbo right now almost, right? Everyone kind of wants to push forward to this new, technology of like AI, right? But security hasn't really caught up with how do we do good, security around AI, right? Is that something that you're also seeing in the industry?
Yeah, and we talk to partners about it. I mean, at Invary, what we do is we ensure that the core of the system is free from advanced persistent threats, so that your operating system, your kernel down to your hardware. And, in the AI space, a lot of people are like, trying to figure out, what do I do to secure this? And, the data, the inference data, the metadata, your training data, it's some of the most valuable assets a company has. And, maybe haven't put a lot of thought into, what am I doing to secure that? And so, we work with DoD, Intel customers, and then commercial customers. So some of the most sensitive AI frameworks. And, we learn from them and how they use our technology to ensure that. So, but I do get a lot of questions. I think you're right. And beyond AI, I think the problem that we're facing is our attack surface is just expanding exponentially. And I'm sure you're familiar, and I talk about it a lot, the threat cycle, where the attack surface expands and then the attackers find a way to exploit it. And then we as defenders figure out they did that, try to stop them, but then we're repeating the cycle already because something else has changed. And so getting in front of that, a lot of what we talk about in Invary and what we need to do, I think very relatable to your comment there. I want AI, the features and power of it are amazing, right? But if I don't secure it, so customers put inference data in there that has their personal information, it gets stolen. Somebody steals my weights or messes up my weights, and now it's giving out bad, improper information. All kinds of things can go wrong. So there's a lot to do for sure.
Yeah, talk to me about your not your experience, with the government, but like working with them, right? As like an outside party. I have a little bit of experience with that, and it was always very interesting seeing like who tries to, push you around a little bit, and it's like the levers that are being pulled and the locations that you go to. I thought the locations part was probably the most fun part for me, right? Like, okay, fly into this airport, drive these directions, don't even give you an address. And
Yeah,
you show up and you're like, am I at the right place?
sure. I mean, so at Invary, so our software is based on a license that we have of technology from the NSA. And then we have a collaborative research agreement with their laboratory for advanced cybersecurity research. On top of that, we also, of course, do business with entities in the government, sometimes through a prime. So like, I probably shouldn't say, but the large primes that are out there into those programs. So a lot of experience across that board. I would say, and to be honest with you, in my background, we've done work in government before and supporting things at those different companies I mentioned, but here it's a lot more intimate. And with the NSA relationship and our collaboration agreement, it's really, I feel like the good guys collaborating, meaning that coming into it, I wasn't sure what to expect, but they're really just security engineers there to kind of make sure we're doing the right things with the technology and that we're helping each other. And I find that very rewarding. I think the goal is to protect all of us, right? And that's sort of what's driving the research, the conversation, the work that we do. And everything else is kind of secondary to it. So I found that interesting. And then, I'm working with the customer. They are very thorough. There's weird timelines and systems and things that you have to do, and we can get into all of that. I kind of think about it though as kind of walking through mud where you're always making progress. It's slow, but they also, some of the brightest individuals are in those programs, really looking at the scope of things. And I think a lot of the requirements, the compliances that we in the commercial world have to adhere to are coming out of this work that's happening in a lot of these places where we're thinking about it to the next level, figuring out how to make it scale, economical, efficient, and then bringing those things back to mind or back to and it's a community. The commercial world does it too, but that's kind of what I see when I work with these entities is, obviously it's a serious thing, but it's also a partnership where we're working together, sharing ideas. Sometimes it's even a disagreement. So a lot of times we talk about the walls that we put in place to secure our infrastructure versus the verification that those walls are doing what they're doing. Relationship there. Nobody can get to my kernel versus I zero trust world where maybe somebody could, so we better verify that a persistent threat actor isn't there. Great conversations to have. And that's kind of been my experience, working in those communities.
So what is NSA licensed tech? I think that's the term that you use there. Well, what is that? I've never heard of that before.
Yeah, and I don't know if your listeners have heard of any kind of tech transfer. So normally you think about it in terms of university. So the university, a professor will do some research and come up with some patents, and that's their IP. And you're like, hey, I think I can make a product out of that. And then you license essentially those patents from them and you pay a royalty back. Turns out the NSA has a tech transfer office as well. So you can go Google search NSA tech transfer. And there's a series of patents and things that they have out there that they're willing to license to individuals. So part of our founding team is a professor of EECS at the University of Kansas who does work in trusted computing, sometimes with DARPA, sometimes with the NSA, and then our CTO, PhD in the space. So we were familiar when this technology came up and said, hey, we're willing to license this out. And there again, you create a relationship that says, hey, I have a business plan. I think I can, use this technology for the greater good. And then you just negotiate a license. They get a small royalty back on money that we make, as an example. And from there, decide to do, sometimes they don't always have a collaborative research agreement. We happen to do that as well in the space that we're in trusted mechanisms. But yeah, it's just like going to university, but you go to a government entity as well. And to be honest, again, before this, I would have been like, I don't know about that. I would do it again in a heartbeat. Very, very smart, bright people, very great technology. And in our case, when I looked at it, I'm like, we find threats that are underneath a lot of things.
Right.
Our demonstration is usually somebody running a bunch of security vendors, and I can still get past that. And to me, I was like, this needs to get out there, right? This is a technology that needs commercial scale. And, that's part of their mission too. So it's a great, I hate to use the word synergy, but a great synergy, I think, in what they were able to offer and what we were able to do.
Yeah, that's really interesting, because you're talking about, one of the top, one or two, right, intelligence agencies in the world. And they kind of have that collaborative experience with the public sector, or private sector, which is, it's fascinating, right? Because typically when you hear about something like that, you're hearing about it from, one of the Israel's, 8200 group people, right? That left the service allegedly. And now they formed this company and they're doing like amazing things, like that's like the only time, that's the closest thing that you really hear of that, in this space, in this world. I'm going to have to look into, their patents and their offerings, because I'm actually getting my PhD right now in satellite security. And a part of it is actually utilizing zero trust in a secured architecture format to secure communications within the satellites for preparing it for like quantum encryption, a post-quantum world, right? So getting that would be very helpful, because I'm sure that they've already looked at something like that, right? And they kind of just need someone to run with it to some extent. And that's definitely something that I'm looking to do, right? Because now that I'm in my PhD and I'm doing the research and everything, I always think, 5 years out, right? So now I'm thinking of, okay, well, what do I do with this? Where do I see this going and stuff like that, right? So that's all a part of it as well.
Yeah, for sure. I mean, a lot of need for what you're doing. So thank you for doing that, number one. And, it's to give you a sense of like the people behind this stuff. They are also the originators of Secure Linux, SE Linux,
Okay.
and push into open source. And so really they're just security engineers, like I said. And then this is my view, so I don't represent them at all. But, I don't know what rules or restrictions they have around publicizing what they do. I know it's not as easy as it is like it may be a university, especially a private one, who has complete control. And so I think it's just maybe a lack of exposure, and they need more exposure to create that benefit for more people. But yeah, definitely worth checking out. And to be honest with you, I'm sure the other agencies have similar programs. Not as familiar with them, but I would definitely look at those opportunities as well.
Yeah, probably at least like the NSA and DARPA.
Yeah.
That would be that'd be really interesting. Yeah, and you bringing up SE Linux there kind of takes me back almost I don't know, it was an interesting experience, like fresh out of college, handed this project and it has SE Linux on it. It was like, oh, what's SE Linux?
Right.
Went down a rabbit hole for 18 months learning SE Linux. So by the end of it, it was like, oh yeah, you have to run, these 15 commands to do this thing. Whenever someone at my company ran into an issue, they were like, just go to jail. Like even the developers that were supposed to be deploying and, integrating SE Linux into our product, like they would go to me and, be like, hey, like what's going on here? Like, oh yeah, well, you guys broke it this way. So you have to run these things and it'll allow it through, right? Like what a powerful solution, in terms of just application security, server security overall, like, I mean, that's amazing what they built. And then they released it out into the public. I couldn't believe it when I fully understood it.
Yeah, for sure. And it's got its own language to it, kind of, right? So it is extensive. And I think that shows, I've used the word trusted mechanisms a lot, and again, my opinion, not theirs, but you look at, how are we assuring, we'll talk about zero trust in a minute to kind of go back to your PhD work, some interesting thoughts there, but how are we assuring the things that we are relying on? And so I think of SE Linux as like a lot of work that they put in for boot time security, right? They're like, well, I need some assurance, right, at boot that I can trust kind of what's happened. And then, the technology we license was called kernel integrity measurement. We call it runtime integrity, but it essentially extends that to runtime and saying, are the things that I believe to be true about this particular operating system always true? And so then you're constantly challenging yourself back to zero trust. What are my assumptions, right? So it turns out for a typical security vendor, there's a really bad assumption that like the operating system is okay because I have to ask it a bunch of information, right?
Yeah.
Give me the logs. Well, did an attacker in the middle alter those logs? You don't know. Tell me when a file was opened. Did it not tell you that a particular file was open? You don't know. And so even, going back to satellites and zero trust, a lot of times people think about authorization, authentication. And of course, those are important, but you forget about assets and resources, right? So you can keep going down and then you're like that whole root of trust program. And then we can talk about confidential computing and TPMs and things like that, all grown out of the thinking that I think was the genesis of SE Linux at the time.
Yeah. Yeah, it's, I remember when zero trust, when that term was starting to be thrown around and kind of, I think maybe to some extent Zscaler like maybe coined the term or made it popular, right?
Yeah.
And then it quickly turned into a framework, right? At least I view it as a framework. I think it's a framework, the NIST documentation, I don't use it as a framework. So I think it is now, right? But, with my research, it's like almost going down like a rabbit hole. It's like, well, how zero trust do I need to make this thing, right? To make it secure and completely trustworthy. Do I need a tiered architecture with the satellites, right? Where you have like a ring of satellites around the planet, that then communicates to a higher level ring that has authentication mechanisms around their own, that can authenticate these satellites. Well, how do I verify it? Well, that's going to talk to a dish, back on Earth, right? And that has to have its own verification system. It's It's interesting, right? Because my background, I got my bachelor's in criminal justice, and then I went and got my master's in cybersecurity. And, like you said, right? Well, what's the authenticity of that log file? What's the authenticity of this system? Did it change? Did it get removed or and everything like that, right? During my master's, because it was a very hands-on program, I mean, we learned about how to modify all that stuff, right? Like we learned about the importance of log files. And my professor immediately said, and all that goes out the window when you're hacking something. This is exactly what you do to modify it and make it look like the way that you want it to look. And I mean, I'm being taught by, NSA hackers, NSA people that do forensics. I mean, the smartest people on the planet, and they're literally saying, yeah, like last week I was doing this on a target and this is how I overrode it. They'll never know any different because they don't do this other check over here. And so
Right.
you have to have all of these checks in place. It's fascinating stuff. How deep you can go with this technology, with this space. There's almost no limits.
Yeah, I know. There's a couple of things that stick out in my mind there. So we're advised by a retired NSA individual who did a lot of the inventions that we talked about. And he likes to remind me that you have to think about how a computer works. And it's actually interesting how many cyber professionals and even software engineers sometimes don't understand how a computer works.
Yeah.
Down to disk and memory and the kernel itself and how it's getting that information to know that an attacker can circumvent you in these ways. And it gets very esoteric. The flip side of that coin, and toss it back to you, is I think it's our job to simplify this for the enterprise and government space, right? So
Yeah.
it can get extensive, right? So how do I ensure the authenticity of a particular thing, implement zero trust in an economic way? And that's kind of what we look at, is from an organization of 20 people to an organization of 1 million people, or however large you want to get to. How can we scale that and solve those problems for them super fast? So as you're going through your research, I'm sure you're thinking about that too, right? Like you can do it once, but can you do it, in times and scale that?
Right. Yeah. That's kind of that bridge between the government and, the private sector, right? The government kind of, well, I mean, they'll create something, they'll spend millions of dollars to use it once on one target, or develop a whole like framework or attack framework off of something, right? It kind of, they kind of pass it back from what it sounds like, right? With what you're saying with the licensing or the patented, technologies that they have, right? They then turn it back and give it to the private sector to say, make this scalable, right? Like we don't have that kind of, maybe not that they don't have that capability, right? Because when I think of capability, I'm thinking of smarts, intellect, that sort of thing, right?
Right.
But their mission set isn't to make it scalable for everyone. Their mission set is to make it and work to protect America. And then from there, what goes on with it is beyond them, right? And that's a fascinating bridge that not many people talk about or even know about. And to your point, right, with understanding the underlying, processes of computers and how it kind of operates, right? I'm not that deep, right? But I know enough to where I can start pointing in the right direction and things like that. And I have a friend who says he's very experienced in security, been in security longer than me for sure. He said as security professionals, we typically earn our paycheck maybe 2 to 3 times a year. And what that means is that when no one else in your organization can figure out what's going on, it's typically the security guy that is the one that has to step in because they understand the networking perspective. They understand the systems, the database, they understand the kernel level. That those are very difficult things to understand. And the security person is the one that's typically pulling it all together, tying all the dots together. Right. And that's a difficult thing. And you really only learn that by going deep into these areas. I feel like early on in your career to build that foundation, like for myself, I didn't really understand virtualization until I sat down with an engineer and I said, okay, how is this tied together? Like
Right.
actually show me the port, the socket that is using, how do I terminate a socket, all that sort of stuff, going through it. And I mean, that took me a couple of years, right, to really understand it and, be able to make my own troubleshooting deductions from it,
Right.
but it's a step that's really, it's really required if you want to be successful in this space.
Yeah. I mean, in there, the interrelationships between all the systems, and as a security professional, having in it, you're going to have to understand them, does give you a leg up in a lot of, what's going on in the environment, and helping, lots of people out 100%. So it's more than just how a computer works. I think that's a good point, right? It's how does the system work together with all of the computers in it, right?
Yeah.
And being able to make those determinations. And then,
Yeah.
at least for me too, it's complex, right? So you're like, oh my gosh, I need to make it better. And then, if there are folks out there that it's sometimes hard to hire, very exceptional professionals that can do that. So how can we help these people? And I think that's the problem that we face today that Invary tries to solve, lots of other people are trying to solve is, I talk to CISOs all the time, and they're busy and stressed all the time. And they have a lot of pressure on them, at the same time. And so it's clearly as an industry, we have a lot of work to do, to make that easier for them and stay on top of the innovation that's happening. So all the way back to AI, right? Like that CISO is like, oh, I got to have an AI. It's so powerful for, maybe a large retail chain. I have to do it. But now there's this whole other set of interrelationships and problems I haven't thought about in zero trust. And boy, what am I going to do to put that together? So I think that's great. As you're going through your PhD work, as we're thinking about how do we scale this for, commercial use and the technology license, it's those things that go into it, which is how am I making this easier? How am I solving exponential problems for those people? So we can get in front. I don't know if you're a Star Wars fan. Are you a Star Wars fan? Yeah. Okay. So the scene where they're in the trash compactor, yelling at Leia to get on top of it, almost every day I'm talking to somebody and they're underwater, I'm thinking about that line of like, well, get on top of it so you're not buried in the trash, right?
Yeah.
And so constantly, what do we need to do to get on top of it? Which is, the behaviors that we do are interesting, and really what attracted me to the technology when I saw it at the NSA is instead of like looking for bad things, which we need to do, this kind of flipped the script and it's saying, no, I'm just telling you that everything is doing what it was supposed to be doing. And so, of course, the absence of that means that something bad has happened. But what that means is I don't have to go look for 1,000 unique threats. I have to just go look for one alteration to proper behavior. And so that's how like our minds think and work is like, am I solving these security problems for the world? How can I apply different frameworks, techniques, thoughts around zero trust in such a way that reduces the number of tools, the amount of time, the amount of decision making that these folks have to have?
Yeah. That's it's really interesting. Staying on top of the technology evolution, right? That reminds me. I was doing some consulting work on the side with a state-run, government institution, and they wanted to have an AI model that ingests all of, kind of like the safety and infrastructure, safety, security of their state. And they wanted to have it to where, you could ask it questions of what are the top 5, bridges that are at the highest risk of collapsing within the next 3 years, so that they can prioritize properly, right? Because they were getting all of this data in, but by the time they would get to the critical stuff, it might have been too late. It might have, caused more issues. They might have been spending more money when they shouldn't have been. And so they were creating it, and they said, yeah, we're almost done with it, but we just realized we didn't even like check if we secured it. Like we kind of need to create this as a copy and paste sort of thing where it's like, hey, you just copy this GCP project and you paste it over here and it has all the security controls built in and whatnot. And so we need you to come in and tell us, how to do it best, right? And it's it's an interesting task, right? Because where else am I going to get that sort of experience? What other opportunity out there will I get to look at an AI model that's doing that sort of thing and see how do I secure it? How are you authenticating to it and all that sort of stuff? It's really fascinating. And to your point too, trying to stay on top of it, that's like a day job in and of itself, just trying to stay on top of this stuff.
We keep cyber is a big industry and it's like good for a company in cyber, but really it's bad for us as a world and a waste of GDP in some cases. And so it keeps getting worse. I don't know if that's exactly true, but you and I could probably chat statistics that kind of show that things are getting worse. But I think it just comes down to what can we do to be in front, right, of the attackers. And, there's a lot of things. It goes from security and design. So kind of what you're saying, ooh, I should have maybe made the system before I secured it. But that has to be easier. I mean, there's a reason people aren't doing it. So it's expensive, it's hard, maybe it's not taught. So there's that part. And then the solutions that we have to be innovative in such a way where, I don't have to have tools upon tools and spend enormous amounts of energy, time, and money to figure things out. I'm very interested. AI is a good portion of that, right? Both protecting it and then using it for those things. But to me, that's the challenge. We have to also communicate better as the good guys, right? I get to work with universities and government entities and commercial entities all the time, so I'm lucky. I don't think lots of people have that opportunity. I like you still you had that luck in your experience too. So how can we get your listeners, more people, to be involved with larger groups of people in a non-competitive way where we're all just trying to get ahead, to get on top of the pot, stay on top of it. That's it.
Yeah, we've kind of danced around it, but why don't we circle back, so to speak, to your company, right? What's the name of your company? What are you guys trying to solve, and how are you doing it?
Yeah, sure. So it's Invary, short for Invariance, and we ensure the security and confidentiality of systems. And we start at the operating system because that's the core of assumptions being made that isn't validated today, down, as I mentioned, to hardware and validating. For instance, if you're aware of trusted execution environments and confidential computing, they are meant to ensure that when you're on a VM, only users of that VM can see that memory, and it's encrypted in such a way where the host or other VMs on that can't see it. Is that hardware doing what it's supposed to be doing? So we do a lot of proper behavior attestation at runtime. So a lot of that boot time security we extend to runtime. Again, based on, that technology that we license from the NSA. And then real quick on how we do it at a high level, let's talk about the operating system for a second. So it turns out that we can map in a graph data structure, behaviors of an operating system. It's about 1 million data points of data structure, objects, relationships, code sequences. And I think about them as constellations. So you think about 1 million data points, that's a lot. But if you think about like our night sky, constellations, Big Dipper, I know where it's at. I know where it should look like. It has an invariance to it, right? So if I look up and it's changed location, changed shape, something's gone terribly wrong, we don't probably have a lot to worry about. So it turns out with software, it has some of those invariants built into its design. So the kernel is designed in such a way that has these invariants in it that you can map. It's a lot of the IP that we've got from the NSA has that definition of those invariances. So we baseline an operating system, and then at runtime, we never have to have seen that machine before. We grab that same map very efficiently, pull it up, and then essentially compare the constellations and see, hey, are they doing anything different? And if so, that difference is probably almost assuredly an attacker implanting themselves in the middle of one of those data structures.
Huh. Yeah, that's really fascinating. It's interesting how something like this hasn't really existed for the most part, up until now, right? Because I'm thinking back to when I was like managing, Bit9 before they got bought out by VMware and everything else, right? Where, you would have to do research into the process, into the service, and how it's actually, hooking in everything. And I remember sitting there being like, can't someone just put something together where it just, builds a model off of this? Like, there's no way that Microsoft doesn't know what their OS is doing and the expected services and stuff like that. Like, why can't we just, have that and then map off of that, and it's, when you build it in like that, you're starting with security in a very good place. I mean, how much better can it get from there?
Yeah, if you
there's
could
other
measure
layers to it.
everything, you would, right? If you could say push a button and know that your entire system is doing only what it's supposed to be doing, you would do that, right? As opposed to the flip of like running a bunch of software to look for bad things. Now, I think traditionally it's been mathematically hard to prove and do. So like I mentioned, Dr. Alexander, one of our founders, he spends a lot of his research time mathematically proving attestation and trusted mechanism techniques. So we know they can be true. And then now you have to make it perform at scale. Again, going back, I don't want to say or even know how much time NSA spent researching this just for kernels, but it's probably quite a bit. right? It's a lot of IP that went into what to measure, how to measure it. We put our own IP on top of that. So you do have to make it scale. And I think if you think about bespoke applications, then they get unique, right? So you have to know a little more about them. So now there's a relationship, I think, with the developers of those applications and metrics that they know are important. But it also turns out, at least from our perspective, the relationships between applications and the kernel also have an invariance to them. And so like, I'll use the Log4j example. When it got exploited, it used different code paths and sequences that it normally doesn't do. Effectively, in my opinion, violated an invariance of the purpose of the design of that particular application. So I don't know. Are you familiar? I'm sure you're familiar with the Log4j exploit from a few years ago. So you can start thinking about it like that. And then I like to think about it as you're a really cold person and then putting layers of blankets on you. Right? I don't have to make you 100% warm right away. But if I can add a lot of value by making you slightly warmer over time, that's worth doing. So start with the kernel. We moved up on Linux to eBPF, which a lot of security and network optimization companies are using. So we're making sure it stays secure because turns out it's being attacked quite a bit. And then moving up to applications by looking at the relationships with things that we know have strong invariance to them at the same time. So, traditionally has been difficult, computational, but fortunately we found a way to make it super performant, which you have to when you run on some of the platforms that we run on. It has to be non-invasive to the mission of that machine.
Right. Yeah, that's really interesting. And then being able to potentially like hook into it to create, basically blocks in the system and, secure it further and things like that. It's a fascinating space. And I feel like Bit9 was one of the first players in this space and it kind of died off, right? And everyone has tried to kind of build a product around, that sort of functionality, right? Of having that in-depth look at your system and building in, like what you said, the invariance of, hey, this is so far, outlying in what's normal for your system. We should look at it more, and building in that sort of functionality. It's really fascinating.
It's closely related to anomaly detection, right? Which also has a lot of value.
Okay.
But it's steeped in knowing what's supposed to happen, right? So sometimes with anomaly detection, it's a lot of investigation. I don't know if you've experienced this, like in my teams, myself, you get a lot of fatigue, right? And so you don't right. And so that's like for us, we tell our customers, if you get a signal that you don't have integrity, that is a step one. There's no need to investigate that, right? That is like, and we've proven that over and over, and that's kind of steeped in the work that came before us as well. So we've benefited from that. But I think that's where we need to get to, where I can tell a forensics person or a response person, this is a fact, essentially, and why I know it's a fact. And then that gives them a much quicker ability to respond, and then they don't have to worry about the noise in and around.
Yeah. Yeah, it makes a lot of sense. Well, Jason, we're basically at the top of our time here. It was a fascinating conversation. I think we're definitely going to have to, have you back on and, potentially even have on, some of the advisors that you were mentioning that are doing some of that research. I think that'll be really interesting, really fascinating to hear from them as well.
Yeah, we'd love to do that.
Yeah. Yeah, absolutely. Well, Jason, before I let you go, how about you tell my audience, where they could find you if they wanted to connect with you and, learn more about your company and whatnot.
Yeah, sure. So it's invary.com, invary.com. You can reach me at jason@invary.com or info@invary.com. I'm happy to answer any questions or help anybody out.
Awesome. Well, thanks everyone. I hope you enjoyed this episode.